In this video, we'll be talking about the slopes of parallel and perpendicular lines. So first off, we all know that parallel means two lines that never cross each other. So the rule here is that parallel lines have the same slope. Now, perpendicular lines are lines that cross and form a 90-degree angle. A lot of people mix up perpendicular with just regular old intersecting lines, and lines that intersect don't necessarily create a certain type of angle, but perpendicular lines do. That's where you get those 90 degrees, and that's that square corner. So your rule for perpendicular slopes is that they are opposite reciprocals. Opposite reciprocal slopes. Okay, so these words opposite reciprocal have very specific mathematical meaning. So the word opposite really means that you change the sign of a number. So for example, 3 and -3 are opposites because one of those is positive and the other is negative. It doesn't matter which one is which, it just matters that you have one of each for them to be opposites. And reciprocal means that you take a fraction and you flip it. So let's say we have the fraction 2/5. Its reciprocal is 5/2. So there's our two rules, and just the thing to remember with perpendicular slopes is that both of these have to be true. So for example, let's say we start with a slope of -1/2. Then this opposite reciprocal slope has to change from negative to positive, and the fraction needs to flip. So it would be positive 2/1. So we would say that these two slopes are opposite reciprocals. All right, so I want to show you really quickly about how this looks on a graph. So we've got a line graphed here on the page. Has a line. Sorry, the pink line has an equation of y equals 1/3x minus 1. So our slope here is 1/3. Now, if I want to graph this next line in blue, notice that it has the same slope, but a different y-intercept. Now we're starting at -5, but we're still counting rise over run 1/3. So I'm going to rise 1 and then run 3 and make a point. So up 1/3. And there's my next point, up 1/3 again, there's my next point, up 1/3. And you notice that the blue line and the pink line rise and run in the exact same way every time. The pink one, every time it goes up, it also goes over 3. Same for the blue. And it's that same rise and run that causes them to never ever cross. So there's a really clear example of the same slope causing two lines to be parallel. And then you'll notice with the green line, we have the opposite reciprocal. So you flip 1/3, you get 3/1, and we'll change it from positive to negative. And now we have an opposite reciprocal slope. So let's just graph this to see this in action. We have our y-intercept of 9. So we'll count up 3, 6, 9, there's our y-intercept, and now I'm going down 3/1 because my new slope is 3/1 and it's negative, so down 3/1 again, down 3/1 again, and again, and again. And if I connect these dots, you see how the pink and the green lines, well, and actually the blue as well, they cross at that 90-degree angle. So we can see how these opposite reciprocal slopes cause that perfect right angle between the two lines that are parallel and this one that crosses them. All right, finally, let's do a quick example where you're given the equation of a line and you have to find a new equation of a new line that's perpendicular to the first one and that passes through a point. So really what this problem comes down to is writing the equation of a line, finding the slope, and finding the y-intercept. Now, we've got a clue here because we know that the line that's perpendicular has a slope of negative 2 over 3. Well, if the two lines are perpendicular, then that means that our other line should have an opposite reciprocal slope. So the opposite reciprocal of negative 2 over 3 would be positive 3 over 2. So right off the bat, we know that in our new line, the slope is going to be 3 over 2. All right, so let me just erase all that. Now, the second part of this problem is finding the b. So here is where the other point that we're given comes into play. Because we've got a slope now, we can use this point that's given as an x and a y. So we can plug in the x into the equation, plug that y into the equation, and now we've got a number for m, x, and y. We can use all those numbers to solve for the b. So that's what we'll do next, is we'll take this point, 6 and 7, that 6 is my x, 7 is my y, so I'll plug everything in. I've got, here, let's do it off to the side over here. Y is 7, so I've got 7 equals, we know our slope m is 3 over 2, and then our x is 6, so 3 over 2 times 6, and then plus b. So it's okay that we don't have anything to plug in for b because we're going to solve for it. So if I solve this, I've got 3 over 2 times 6 is going to give me 9. 3 times 6 is 18, divided by 2 is 9. So I have 7 equals 9 plus b. I'll subtract 9 on both sides, and that gives me that b equals negative 2. Boom. Now, not only do I have the slope, I also have the y-intercept. So now I have enough information to write the equation of the line. So we'll bring it all together. Our equation is going to be y equals 3 over 2x minus 2.